In this video we present new recovery methods for industrial assembly problems in human-robot interaction tasks. Therefore, we took up the future trend of human-robot collaboration and arranged a scenario in which a failed assembly process must be recovered by a human who not necessarily has technical knowledge about robots. In this context, the question arises which input device or interface is the most appropriate one for user intervention. Thus, we set up a user study with 31 participants in which the users had to solve exemplary assembly problems using different interaction methods. For this purpose, we designed two components to be assembled automatically. The first one is a shaft with two mutually displaced keys. The second one is a conrod-like part with a notch. The conrod-like part is fixed to the robot and hence serves as its end effector. While the robot mates the conrod on the shaft, errors can generally occur. To solve those errors, we implemented four possibilities to interact with the robot: a control with the space mouse and a control with the keyboard due to their widespread existence in industry. Furthermore, a kinesthetic teaching mode to control the robot by hand, and last but not least, a modified version of kinesthetic teaching with a contact situation adaptive stiffness. In addition to the interaction modes, we added a three-dimensional visualization which helps the user along to see which forces are working on the shaft. This is shown in the bottom video frame, while the top video frame shows the whole scenery. The video on the right shows a close-up of the first assembly problem, which is triggered by a tilted conrod. As the Cartesian impedance controller was not able to cover this problem, the resulting forces gained and the process stopped. In this case, the top assembly problem is exemplary solved using the space mouse. Driving on, the robot will face the bottom assembly problem. It rotates too much around the shaft axis. As a result of this, the notch of the conrod will not be able to pass the shaft's key, what we can see in the picture on the right. To solve this situation, we took the kinesthetic teaching mode as an example and helped the robot getting on the shaft's bottom key. To evaluate the incorporated user study, performance criteria like jerk, arc length, time of completion, total effort, average speed, and user satisfaction have been used. The results from the user study show that kinesthetic teaching is the best method for interaction in the presented industrial assembly scenario in terms of both performance and user satisfaction. In scenarios similar to the considered one, where humans are interacting with robots, it is possible to record how assembly problems are solved by the human coworker and later use this data for automatic recovery if the same assembly problem occurs again.